Okay, so we're back to homeostasis. Homeostasis is the process using all the organ systems to maintain temperature, ionic concentration, blood sugar, and we'll explain negative feedback in a moment. But it's very important to keep your temperature around 37 degrees centigrade, to keep the ionic concentrations of sodium in your extracellular fluid, of potassium in your cells. Your blood sugar has to be controlled, otherwise you have diabetes. Keep eating the standard American diet and you'll probably get type 2 diabetes. Eat a plant-based diet and you won't. The standard American diet is sad. I'm struggling all the time to eat more plants and to get rid of meat, dairy, and so on. All the research is showing that plant-based diets are much superior. So again, homeostasis is the process of all of your organ systems to maintain stable conditions of, for instance, temperature, concentrations of sodium and potassium, for example, and blood sugar levels. We'll talk about negative feedback in a moment. In order to do homeostatic regulation, you have to have a receptor. So a receptor is the first thing. If your body gets too hot, the receptor is going to tell the central nervous system and tell an effector to move blood to your exterior surface so that you can lose heat by radiation, through sweating, go into the shade, go into your house. Hopefully you have air conditioner, but a receptor tells your central nervous system that things are getting too hot. If you get too hot, you die. If you get too cold, you die. So here's an example using a thermostat. So if the temperature rises or the temperature drops, so the receptor is going to tell the thermometer what's happening. The control center is going to turn the effector to return the temperature to normal. So this is analogous of the process. So let's look at the process coming up. We're going to use negative feedback. So if you get too hot, homeostasis is going to negate the disturbance. So if you're very, very hot, you'll start to perspire. Blood flow will be routed to the exterior. That's why you get red in the face. Radiation will remove heat from the blood vessels from the blood, and you'll negate the rise in temperature. And how do you do that? So here's our receptor. So if the stimulus rises above 37, the receptor alerts your control center. Blood vessels and sweat glands start to function. So blood flows to the surface, increased blood flow to the skin, increased sweating. So the rise in temperature is negated. Okay. So here the body temperature is going to fall. Suppose it falls, what's going to happen? Just the opposite. Decreased blood flow to the skin, decreased sweating, shivering, putting on a jacket, going inside. So the blood vessels and the sweat glands do not function. The blood vessels route blood away from the skin. The skeletal muscles shiver, and that's going to return your temperature. It's going to blunt that and raise your temperature by keeping blood away from your surface, stopping sweating, and doing shivering. So homeostasis negates the change in order to keep your body temperature at 37. Here we have just enlargements of both sides of that diagram, so make sure you study these and understand negative feedback. Is where temperature drops, it tells you what happens. Here's another view of that same process: receptor, control center, effector. That's negative feedback. Positive feedback, let's stop there and go back to the meat and stop recording, and we'll have a short video that I'll be posting.